Hello guys, today we will cover some search algorithm. Imagine that we have a data, some data, and we have to search for it. We have to search for some value. Let's say we search for 8. If we search from the very beginning, it will take us 8 iteration, take 8 steps until we find 8, right? If we start from the end, from the tail of the list, it will take us 2 iteration, 2 steps. But imagine if we have a list with 1 million items, so you may be very unlucky to find something really fast. It may take some time because you will need to go through each and every element until you find it. This search, when you're going through each element, is called linear search. Linear search is something like that, or n. This is a complexity. I mean, this is how fast it is. And the binary search that we will cover in this session, and this session meant to be a coding intro session. It's one of the most often asked question, frequently asked question about to implement the binary search. Okay, so the binary search is faster because it doesn't do this. It doesn't go linearly one by one, and its speed is faster as O logarithm of n, where n is how many elements in this list. The way it works, it doesn't start from the beginning. It doesn't start from the end. It starts from the middle. Okay, and it tries to search through. Let me just give you some scenario. We're searching for 8. We take in this middle index, middle value 5, and we checking whether 5 is less than 8. If so, we will be going to this side of the data. And I forgot to mention, to make it work, this data, this list has to be sorted. Otherwise, you cannot apply binary search. You have to sort it first, or keep sorted. Okay, so once again, we start from the middle. We're searching for 8. Then we split it in 2. I mean, we will take this part of the list, starting from this 5 to this 9, because we figured that 8 is on that side, on the right side. You see what I mean? Then on next step, we will take another step. We'll take another middle of this list, and this time we will compare middle element 7 with 8. 7 is still less than 8, so it will go further until it finds it or doesn't. Okay, same way it works if we're searching for something that is from the left side. Yeah, and imagine if we search like that to find 8, it will take 3 iterations, 3 steps, not 8, right? And especially it is efficient, especially even more efficient for bigger for bigger lists when we have a lot of data. Okay, and here we defined some steps, what I just mentioned. So basically we split in the step 1, we split in algorithm, we split in the list in 2 by some middle value. Then we get in this middle index, middle value, and we compare the middle value with target value. This is what we just did. So this is just a beginning of the implementation. Before doing the implementation, we just defined these kind of steps for now, just simplified version. And these two steps are not enough to finish everything, of course, but at least there is something. So we can start with that, and then we'll clarify these steps as we go. At least this is what I'm going to do right now. Okay, well, this is our main function. We will start working. Then we're supposed to have a search function. But we don't have it yet. And this search function will get a result. And we will print this result in here. We know that we have a list, which we still don't have. Let's just define this list. The list with data. I think we have to have an array list. This construction will create one. We can take this as data, beginning from 0. So it's nice to have this data beginning from 0 because the index and the value will be the same. Easy to reason about. Then what we're gonna do? We'll pass this list as an argument to the search function, and we expect to have a result. Yeah, but what we're searching for? We're searching for some target value, let's say for 8, like I said. Okay, so we'll pass a list, then we will pass an 8. Actually, let's flip it. It's kind of more logical to say what we're searching and then where we're searching, right? Maybe it's better, right? Okay, so let's start with that for now. Create method, create method for us. This will be a list. Oh no, this is a target value, a list, and it will return us something like integer. Let's say for now it returns -1. Let's say for simplicity, -1 means that it didn't find anything, at least for now. Okay, let's go to our steps because we have to stick to the plan. Our step number 1 is split this list into 2 lists, right? How are we gonna do this? We have to find a middle index, first of all, right? Find a middle index. Yes, and then by this middle index, we'll get the value, the middle value. So technically, we are not splitting anything. We just imagine that we're splitting by taking the middle value. Okay, so we kind of clarified a little bit here what we're gonna do. So we will just need right now to implement these two functions, I believe, right? Let's do it. Find a middle index. Okay. Get a middle index. Maybe find also good naming. Private static int. So this is gonna be an index. And right away, middle value. We know that it will take list. It has to, right? At least a list of integer, same thing, integer, okay, value. And we know that to get a value, we just need to use the index. There's nothing much here going on, it's just mechanical work right now. As you can see, we're not even thinking, we're just filling the gaps. So the real work will be here, just to identify what is middle value. All right, we can implement it right away. Maybe not really super correct, but it's gonna be our first approximation. We know that if we pass in the list here to get a middle value, it will be probably just enough to divide it by 2 and return something. Right? Let's continue. Get middle value, right? Get middle index. So most likely we need them right here because we just defined that we need the steps, and we probably do need them. Then we'll just call this list r. It's gonna be middle index, and value. I'm not sure we need both of them, but just let's define them. Okay, get middle index, get middle value. And right now, this second step, we can implement it right away. Some kind of if condition. The if condition is supposed to be inside search, and this is also supposed to be inside search, because the whole work is inside search, because this is what we do, implementing the search. Okay. Right now, this if condition, if middle value is more than target value, it means that we will be searching on the right side. Right? Let me check. So let's say we're searching for 3, right? And then middle value is, let's say we're searching for 4 and middle value is 3. It means it's the target value that we search for is on the right side. So we will be looking to the right, right? Just let's put something like look to the right side or something like that. It's a comment. Look to the right side. Otherwise, if middle value is less than target value, so let's say if we're searching for 1, right? It's actually opposite. Yes. So if we're searching for 1, it means that middle value 3 in this case is more than target value. Okay, then we'll be looking to the left side. Else, if it's not less, not greater, then it equals. It means that we found what we were searching for. Return target value. We can print something like found it. Right now, we have to fill the gaps with actual implementation. Um, let's think about it. Okay, let's continue. Um, uh, we have to implement search, right? Right now we have this get middle indexes, these functions, and we have to use them. That's why we define them in the first place, right? So we're gonna use them. This will be uh, middle index, then will be a value. As we define the second step, we're supposed to check, right? We're supposed to check whether middle value greater or less than target value. Target value is what we're searching for. So good enough. If middle value, let's say, is less than target value. What does it mean? It means that we have to search at the right side. I'll explain. So let's say we're searching for 4, right? Then the middle is 2, and 4 is actually less. I mean, 2 is less than 4. So this is exactly that case. It means that our target value is on the right side of the list. So on next step, we're supposed to split list on 2, kind of, and use search and pass this data to search somehow. So let's put this as to do. And yeah, we can think about it afterwards. For now, let's define a flow. What happens otherwise? Otherwise, naturally we'll be searching. So this is like a right, and this is left side, right? Look to the right, look to the left. Otherwise we found what we were searching for, and we can just print it. This is just for us for debugging purposes, and return the value as a proof that we found it. Okay, we'll put this to do. We'll figure out later like as a edge case what happens if we couldn't find it. For now, we're not thinking about it. Yes, the thing is, let's look at this first case when we have to look to the right. As we know, as I said, every time when we search, our search area is supposed to be less and less, reduced, right? Let's say if we search for 8, then we somehow have to let search know that it is supposed to search in smaller list. We could pass a list itself always again and again, but I just know that it will not be a good idea because it will slow the search. Because search is supposed to be as fast as the logarithm of n, right? And what if we do some kind of operations like copy an array or list or something, it will add to the performance. Not gonna be a good thing. But we're not gonna think about it too much right now. And what I'm saying is we have somehow to let search know where we're searching from. So if we pass something like start index and end index maybe, or even start index and for and the size, the length of this next sublist, it will be enough. Something like that. It should be start index and length of that index, right? In this case, start index is 5 and the length is 5 if we're searching for 8. So that's what's going to happen on next step. Okay, and once we defined it, then our search will suppose to take this argument. Let's say 0. The start index from the very beginning will be 0, right? And the length is always the size of the list, I think. And let's define this argument here. Int start index, int length. For short, it's going to be just len. Okay. Make compiler happy. So that's our expectation. Right now, as a next step, we have somehow defined what is this start index and length, because it's not going to be always 0, right? So we know that this start index and the length always will be changing over time. Knowing that, we will define some other variables actually, and name them somehow differently. A new start index, let's say. Let it be equal for now, and var new len, and let it be equal to len for now. But just to note that we have to do something about it, and we're not supposed to use the same values, right? New start index and new length. Okay, let's think about it. We have a middle value, we have a middle index. It's nice, that's what we have, and we have to somehow to define this new start index and new length. But let's concentrate on the task again. So what's going on here? We're looking if this condition is met, we're supposed to pass a new start index. Okay, let's look at it again. We'll just take in our data as they are from here, just to make it nicer so we can see them here right away. So on first run, the middle will be 5. We're looking for 8. And then new start index in the very beginning is 0. So it's 0. Then we're supposed to make it 5. This get middle index gives us 5 actually, right? And this will be the beginning of our new list. So new start index, I believe, is the middle index, right? Because 5 is a middle index. And what is length? The length is, in the very beginning, is 10. But just because we want to define this list right now, on this iteration, we know that length of this list is 5. But we cannot just simply put 5, right? We have to somehow make it dynamically available. So for that, we can use this length. Let me think about it. So we have 10, and we have 5, and we have to get, we have index 5. So what if we do this? Actually, the list size the size of the list 10, right? It always will be 10 actually. And if we just do this minus this index, middle index, will give us 5, right? Yeah, so 10 will give us 5. The next step, if we go on next step, it will be, I'm just checking myself, basically literally writing here, drawing kind of inside. So next thing, step, we'll have this list, and the size, this size is still 10, and the middle index will be 8, which give us new length of 2, which is correct. Yeah, because there are 3 of them, it will split it on 2. It's like a best effort. So that what will define, I think, new start index and new length. But we have to test it somehow. To test it, yeah, we can just run this and see what's going on. We're searching for 8. No, nothing much, right? Stack overflow exception. Yeah, I'm not expecting it to work. There's something wrong with middle index, and I think I know why. Here we don't just we don't do anything. It's always returns 5. That's it. If we print it somewhere, we'll see. But it's not supposed to be always 5, right? It should be changing over time. So middle index. Let's see what's going on. We of course can debug, but just sometimes when you work with if you work if you do an interview, you not necessarily can debug. So, but you can print stuff. Let's just see what's going on. Yeah, I see 5, 5, 5, 5, 5, 5. That's it. So we have to figure out how to make this more dynamic. Because right now it's literally hard-coded. We probably have to pass this index and this length because this is what we have. This is what makes us dynamic in a way, right? And we'll start from there. Okay. Int, and then I'll be thinking again, as usual. Start index length, mechanical work. Here we go. So we have something, and from there we can try to figure out how to implement this middle index. First of all, right away we see that there's something wrong. It's not supposed to be list here, right? We know that it's supposed to have a length divided by 2, and we know that length is always changing, and the length is already integer, so we'll be splitting it by 2. What we also can do is just test this get middle index separately to see if it meets the expectation, because I don't see right away what should I do, right? I'll just need to do some kind of testing. So we're going to test this middle index. We'll comment this for now. Middle index. We'll pass the list. What else it has? List start index, let's say 0, and the length. This will represent the first iteration. as we go through our flow. Something like this. I'll print it right away so we see what it gets us. What is our expectation for this case? The get middle index for this is going to be 5. Right? Then what is our expectation if we're searching for 8, for this 8, and then our start index is 5, right? The length is 5. Then what should be the middle index? The middle index should be 7. So this is our expectation. It should be 7. Let's test it. So it should be 5, 7. But it will not be because we haven't changed code for that. But at least we will see 5, I think. Let's see. Let's see. Exactly. You see? 5 there, but here is a 2. But it should be 7. Okay. That helps actually. We just need to make this 2 to be 7. So in this case, we have a list, start index 5, right? And the length 5. So easy to reason about. Here we go. We know that when we're searching to the right. So it's kind of shifting themselves to the right somehow, right? We are changing the start index. And start index is going from the left to the right. Okay, so we expecting to have 7, but we get 2, and we have 5, which is start. So 5 plus 2 equals 7, right? And it means, so we're just pleasing our test. So this will give us 7 as we want to. And it seems to make sense just because, as I said, we're going to the right. Let's see if our test works correctly. Should be 5 and 7. Here we go, 5 and 7. Let's test again because I honestly don't believe myself. So in this case, 7. And on next step, we want to find actually, yeah, let's say we're searching for 9 or something, not for 8 because it's not going to be enough. So we have this. Our next step, the start index starts from 7. And this is nice to know because you see, it seems like start index will be previous middle index, right? Just to remember this part. 7, so it will start from 7, and the length will be 3, right? So this is this guy. Our expectation is to get 8 because 8 is a middle. And since we just modified it before, we'll see if it still meet our expectations. Here we go. So it seems like we did implement get middle index properly right now, so we may expect to use it in proper manner. Yeah, step by step. Let's comment the thing. We don't need it anymore, but it's nice to have as a documentation. And also we just figured that probably we will use something like that. Start index equals middle index. Let's test it right now. So we know that search works properly right now. Not search, but get middle index. It means that get middle value works properly as well because it just used it. Let's see. Before this, we have to do something about it. New start index, right? Start index equal middle index. Actually, this is correct, I think, because we just said, you see? start index equals middle index. So this is, I think, is correct. New len is correct. Yeah, we already went for it. Let's test it again. We're searching for 8. Oh, you see, we found 8. So it's a good sign that when we search through and we're searching for the left, we actually found it. But then there is -1. What is -1? What it is? I guess it's not important. I'm just returning -1 and not supposed to. Let's comment this out. We'll comment this out later. But my point is that we found what we were searching for. So something is starting to work. Okay. Let's go to the next step. The next step is to define the search to the right side. For sure, we will have this search. For sure, we will use new index and new length. But the scenario, the values will be different, and we have to define this, right? Let's us define what we search for, so it will be clear. We can see it visually. So since we're searching to the right, let's say we search for number 1. Okay, this is one scenario. Another scenario that we have to see it, we should see it and understand actually that from the very beginning, yes, if you're just looking to the right, it seems like start index supposed to be always 0, right? Because we're kind of saying, oh, start this from 0 to 5, to 0 to 2, to 0 to 1. But actually it's not the case. Because imagine if we're looking for, it's not always going to the right or to the left. That's what we have to understand. It actually could go to the right, searching, but then looking to the left as well. So I'll give you an example. Let's say we're searching for 6, and in the beginning, this is middle index. Then it seems we're searching for 6. The 6 is less than the 5 is less than 6, right? We'll be looking to the right side, so we'll take this. Then the middle will be 7, but 7 is greater than 6. It means we have to search back to the left, and that is important part when we are looking at this. And it was very easy to miss it, and then you will get some kind of bug and you have to debug it, and which is fine. There's no problem with that, but it's nice to see the scenario, how it works right away. Okay, that's why I'm just saying here that there are two type of scenarios. We're not going to the one direction only, because for this algorithm it doesn't matter where it is. Not supposed to be fixed to some hard-coded values. It's supposed to be governed and reducing the scope, going to the left, to the right, to the left, to the right, until it finds what it wants to find. Okay. That mostly for myself. I'm just convincing myself that I shouldn't miss this, and it's not supposed to be 0, right? But then let's think about it. What is new index supposed to be? Like we have these two cases. When from the very beginning, let's say we search for 1, but then we have another case we search for 6, which we just described will end up being left search. So if we, so it's not going to be 0. It maybe will be start index, because we know that start index starts from 0, and right now at least it's not hard coded. Let's see if it's right. Let's think about it. So let's say, like I said, we search for 6. Maybe let's start from this scenario. So we search for 1. Then if we start from there, this is our left side. If we use start index 0, it's still okay, right? Then if we search and we split it again on 2, and we're searching for 0, and starting from 0, it's still okay. So it will keep being 0. Not that bad. Then let's look at this scenario. We're searching for 6. We split it on 2. We're going to the right. Then this will be a middle. The 7 is greater than 6. Then we're going to the left. So we have 7 as a middle, and then it means this is a middle, then this is like a left side, and this is a right side. I mean, this is left, this is right. But what is interesting is this is middle, right? And this is start index. And it will define exactly that scope that we're searching for. My point is, if we use start index, it's still okay, because it will say 5 is start index, and we're looking on the left side in this scope, right? So it's still okay. And in this case, we know that length is supposed to be 3, but yeah, let's discuss this. Let's talk about new length. So as we described before, let's say we're on this step where the start index is 5, middle index used to be 7, and right now on next step we have to define new length. And new length in this case is going to be 2, because 3 divides by 2, rounding it, and it's going to be 2. All right, and where we, by the way, we'll find our 6. So how to make a 2 out of these two numbers? Because this is what we have. We have this number and this length, including this number, right? 7, which in this case, 7 is kind of length if from the beginning, whatever. My point is, we have to have 2, and we have 7 and 5. What it could be, right? Okay. Middle index minus start index. And again, this is kind of a guess. Let's check on this, because this will give us 2. Let's test it with this side, with this scenario. In this scenario, we're looking for 1. Then a new length. Let's say we have to go there. Then new length will be middle index. In this case, middle index is 5. It's going to be 2. It's like 2. 2 minus start index, and start index is 0, which will give us 2, which is correct. Yeah, I guess it should work. Let's test it. Hope you are not lost here, because I'm almost lost here, and it requires like some testing. Let's test it. So we're searching for 1. in this case. We found one. Cool. Let's search for 6 because we know that 6 could cause us issue as well. So it's gonna be result 1, result 2. Start what I just did. Just define it again. Okay, I got it. 2. So we're searching for 6. Can we find 6? Okay, we found 6. We found 1. So this seems working. Let's test something else. Let's try to find 9. It works. What else can we test? Let's try 0. Search for 0. Yeah, it works. So the very last thing I have to test is what happens if we search for something that doesn't exist. Let's test something that doesn't exist. Let's say we search for 11. There is no 11, right? And actually it fails. So this is that edge case. But we see something like middle index is 9, meaning it actually tried to search, but it couldn't. It just we don't have this if condition somewhere to exit the function, and we can somehow define it. Let's think about it. As usual, let's think about it. So it's about search, and we know that length. We see the length is the very last value, basically. So the start index and start index. What about start index? Let's print it. Print it somewhere. Just in here. Start index. Yeah, start index also will be 9. Yeah, 9. My point is we have to define some kind of condition like that. If start index equals to very last size minus 1, right? It means the very last. And it means that we haven't found anything. We can test it if I'm right. Have not found target value. And we'll return minus 1 just for the sake of it. Let's test it. Oh, you see it works. Have not found 1. Not 1, but 11. Exactly. So it seems to me that we covered everything, and this is what this algorithm looks like. It took some time. It's very easy to make a mistake. It's very easy to get lost. That's why people use it for testing, actually. Yeah, for sure we can maybe improve some little things here and there, but mostly this is what it is. Okay, thank you.